The radius of convergence of the series produced by differentiating or integrating a power series is equivalent to that of the original series. Okay. However, the interval of convergence may change due to convergence or divergence changing at one or both of the endpoints. Now, we'll look at that as we solve these problems. Example 1, find the Maclaurin series for f of x is equals to cos x. Now, what I'm going to do is, we know that we can generate this just by differentiating each of these by finding several derivatives of this function and then plugging it into the formula for Maclaurin series. But also we can get the Maclaurin series for cos x by differentiating the series that represents sin x. What I mean by that is this. We have already shown that sin x, so we have already shown that sin x is equals to the sum from n is equals to 0 to infinity of negative 1 to power n x to power 2n plus 1 over 2n plus 1 factorial. So from my previous videos, I've already shown that. Now this series has an infinite interval of convergence. Hence, we can differentiate it to find the Maclaurin series for cos x. So basically, what you're saying here is, if we want to find the Maclaurin series for cos x, we can go ahead and just say that cos x will be d over dx sin x. So and this will be equal to the derivative of this series for sin x. So that will be negative 1 to power n x to power 2n plus 1 over 2n plus 1 factorial. So this will be equal to, we can move the derivative sign inside the summation sign. So this will be the sum from n is equals to 0 to infinite of, now what I'm going to do is to factorize the terms that won't be affected with these derivatives. So that will be x to power 2n plus 1. All right, so basically, I'm not going to differentiate negative 1 to power n with respect to x now. So that's why I factored it out. So what we end up with is the sum from n is equals to 0 to infinite of negative 1 to power n over 2n plus 1 factorial. And then here, if you differentiate this, it will just be equal to 2n plus 1 x to power 2n. Okay, power rule. So putting these things together, this will be equal to the sum. Actually, I can, anyway, I'll just write it here. Negative 1 to power n. And I can write this as 2n plus 1. All right, just leave it as it is. 2n plus 1 x to power 2n over 2n plus 1 multiplied by 2n factorial. So what happens is these guys do cancel. So what you end up with is the sum from n is equals to 0. Actually, I can write it below here. So this equals to the sum from n is equals to 0 to infinite of negative 1 to power n x to power 2n over 2n factorial, and this converges for all um, values of x. All right. So that's how you basically work out that. Um, so this is cos x. Um, in this question, we are required to find the integral of sine x squared as a power series. Now, we have already shown that sine x is equal to, so we have already shown sine x is equals to the sum from n is equals to 0 to infinite of -1 to power n x to power 2n plus 1 over 2n plus 1 factorial. And this series has an infinite interval of convergence. So basically what we can do is we can go ahead and we should be able to integrate it, but now we need to find a series representing sine x squared. So sine x is equals to that, and I want you to pay attention to this. All right, so which means sine x squared will be equal to, now what I'm going to do is to replace that with x in my previous series. So that will be from n is equals to 0 to infinite, -1 to power n, and then here I'll have x squared to power 2n plus 1 over 2n plus 1 factorial. So first of all, what I'm finding is that, okay, now this will be equal to the sum from n is equals to 0 to infinite of -1 to power n x to power 4n plus 2 over 2n plus 1 factorial. And we can carry on. So basically, this is n is equals to 0. We can carry on and now find the integral. So the integral of sine x squared dx will be equal to the integral of this summation and we can all right, I think I'll write it below here. Move the integral sign inside the summation sign and factorize a few things to make it easy for us. So -1 to power n, sorry, over 2n plus 1 factorial, and then we are integrating. Now, by the way, we are integrating here with respect to x. All right, so that's respect to x. So this will be equal to so what we end up with here, we end up with where was I? All right, so x to power 4n plus 2 dx. All right, I need to check that everything is correct. Looks good. So we can carry on. So this will be the summation from n is equals to 0 to infinite of -1 to power n over 2n plus 1 factorial. Now, and this will be for x to power 4n plus 3 over 4n plus 3. Okay, just apply reverse power rule. And so that will be equal to the sum from n is equals to 0 to infinite of, we can put things together here, negative 1 to power n x to power 4n plus 3 over 2n plus 1 factorial multiplied by 4n plus 3.